So starting from where we left, I go back to the definition of A cross B, the cross product, which I said is a new vector C, and this new vector C is perpendicular to both the vectors A and B. It can, so that because it is perpendicular, so C dot A or A dot C will be equal to 0, C dot B and B dot C will also be equal to 0. Then I told you that the magnitude of the new vector, which could be out of the board or into the board, this magnitude will be equal to AB sine theta, which is nothing but the area of the parallelogram which is made between the two vectors A and B in the plane of the board and the plane of the surface, your copy where you are writing. If so, C, the vector C becomes equal to the magnitude of the vector C, which is equal to AB sine theta here, multiplied by C cap. Now, I also established for you in the due course that vector A cross B is not equal to vector B cross A. Like in the case of the dot product, in the case of the dot product, I had A dot B equal to B dot A, because it was A dot B was equal to AB cos of theta and B dot A was equal to AB cos of minus theta, which is again equal to theta, and so the two are not equal to each other. That means they are non-commutative. Whereas in the case of the dot product, the dot product is commutative. So instead, what we obtained was that A cross B is equal to minus B cross A, and the reason being that the angle was in this case sine of minus theta, and sine of minus theta is equal to minus sine theta. Now I introduce another thing. What if the two vectors A and B, B is equal to A, of course they belong to the same variety, so I want to know as to what is the value of A cross A. That turns out to be equal to A into A multiplied by 0, which is sine of 0, and sine of 0 is equal to 0. Also, if the two vectors here, they are anti-parallel to each other, one is in one direction and the other in the opposite direction, that is the angle that they make is 180 degrees, then again A cross minus A, this turns out to be equal to the magnitude of the two vectors will be the same, AA multiplied by 0, because sine of 180 degrees, which is sine of pi, is also equal to 0. Now let me tell you, what are the conditions that AB sine theta, the magnitude of the vector C, will turn out to be equal to 0. So it is equal to 0 in the first instance if A or B or both of them is equal to B 0, but sine theta is not equal to 0. In the second instance, A is not equal to 0, it is finite, B is not equal to 0, it is finite, but the angle between the two of them is, okay, such that the sine of theta is equal to 0. The angle between the two of them is 0 degrees or 180 degrees. So either they are in the same direction or in the opposite direction. Now, allow me to write this vector A as per the definition that I gave to you for vector A, component Ax I cap plus Ay j cap plus Az k cap, wherein, as I told you before in the case of the dot product, that the magnitude A will turn out to be equal to under root of Ax square plus Ay square plus Az square, And similarly, if I write the vector b here, then it will be bxi plus byj plus bzk, and so that I can write the magnitude of this vector as equal to under root of bx squared plus by squared plus bz squared. Okay. Now, I would like to give you the optimum value of this AB sine theta. AB sine theta is equal to AB. When theta is equal to plus 90 degrees, r sine of theta is equal to 1. And AB sine theta is equal to minus AB when theta is equal to minus 90 degrees, so that sine of minus 90 degrees is equal to minus 1. Now, allow me to plot this AB sine theta as a function of theta. The AB sine theta as a function of theta, I've just shown the optimum value when sine theta is equal to 1, then C is equal to AB, and when sine theta is equal to minus 1, then C is equal to minus AB. So, the graph that we get for the product vector, the magnitude of the product vector, it turns out to be something like this. Okay. Now, allow me to go ahead and to explain to you what is A cross B. But before that, I will tell you, I'll try to find out as to what is the value of A cross B, I cross J, and J cap cross K cap, and etc. over here when I return to you after writing the things. Here, I told you that if I represent A and B in the usual manner, which is shown here, AXI cap plus AYJ cap plus AZK cap and BXI cap plus BYJ cap plus BZK cap, where AX, AY, AZ, they are variables, BX, BY, BZ, they are variables, but I, J and K, they are constants, they are non-variables. Okay, so their directions and everything is defined. Now, I give you the results as to what happens to I cross J, and the magnitude will be equal to magnitude of I, magnitude of J, and multiplied by the angle between I and J. So in this situation, the angle between I and J is equal to 90 degrees, and therefore the sine of 90 degrees is going to be equal to 1. So 1 into 1 into the direction now will turn out to be, when I turn it like this from I to J, like I said before in the definition of A cross B, then you can see that I get the vector, direction vector is K cap. Similarly, you can see that J and K, they make an angle of 90 degrees again, and if I rotate this vector towards the K vector, then the resultant will be, because K is in this direction out of the board, and this is my J, and therefore if I rotate this towards this, then the direction will turn out to be equal to what is the X vector, or in this case it is I cap. So here J cross K will be equal to I cap, and similarly when the K is rotated through this 90 degrees, the exercise that we have done, positive 90 degrees, then K cross I will be equal to J cap. And from the definition here, that A cross B is equal to minus B cross A, when the angle is negative, that is, if I go like this, multiply j cross j cap with the cross product with I cap, then the vector will be inside, okay, and that is minus k cap. So it follows that j cross I is equal to minus k cap, k cross j is equal to minus I cap, and I cross k cap turns out to be minus j cap. Of course, if I have I cross I, then the angle is 0 between the two of them. Sine 0 will be equal to 0, and therefore I'll get I cross I will be equal to 0, j cross j will be equal to 0, and k cross k will also be equal to 0. So I can write, if you allow me, that same cross same cap, like before I did, and I can write it as same cap cross same unit vector cap will be equal to 0. So that states that I cross I and j cross j and k cross k, that will be equal to 0. And in the cyclic order, in the order of the cycle that I have just made here, I can show you that there is a counterclockwise or anti-clockwise, or positive sense of rotation is there. Then I cross j, I'll go to next k, and j cross k, I'll go to the next in the same cyclic order, that is I, and k cross I'll come to j in the same cyclic order. So what matters here is a cyclic order. So in the cyclic order I can say else cross next else will be equal to next. This is the method that I remember, and I want you to devise the method where you can remember it. Else means I take anyone, say j, cross next is k. So the next to next will be equal to I cap. I take k, cross I will be j cap, etc., etc. Okay, and I have to understand that the order should be positive sense of rotation, which is anti-clockwise or counterclockwise, and we should follow the order. And next we are going to show that we do follow the order and we are happy. Next, I will not do the, you can do as an exercise that axi plus ayj plus azk cross this vector bxi plus byj plus bzk, and when you do this you use these values in that, and finally you will obtain what I am obtaining over here. But one of the methods, one of the shortcuts that we use here is A cross B here I write in the form of a determinant, and that determinant I write as in the first row the I, j and k. I cap, j cap, k cap, then the components of the first vector ax, ay, az, bx, by, bz, and that is 3 by 3 kind of a matrix is there, and the determinant of this is then resolved we make when we take I, when I take I as I have taken over here, then this column is gone, rest of the things I copy as it is and paste here, AY, AZ, BY, BZ, minus J cap. So I take J cap here, this line is gone, then what I am left with is AX, AZ, BX, BZ, and I copy and paste over here and write it as the determinant like this. And K cap, the next one, I just don't take this, and AX, AY, BX, BY I get here. So then I resolve that, and in the determinant of this order, what we do is we multiply this into this minus this into this. Okay, so this one is plus and this one becomes minus. We put them together, I'll get AY BZ minus AZ BY. Remember, I am going in the ordered system, no disorder. Then in the next one, AX BZ minus AZ BX and K cap AX BY AY BZ, and I obtain it like this. So this is the value of A cross B, and if you allow me to write it as C, vector C, then this vector C becomes equal to Cx I cap plus Cy, the y component, into j cap plus the z component of C into k cap, like things we have done here. A is equal to AXI, this one or this one. Similarly, I can write this one, and that I leave to you. So when it so happens, then I can write that the final value of this C, magnitude C, which is the magnitude of A cross B, this will turn out to be equal to this quantity squared plus this quantity squared plus this quantity squared under root. And this is how we can calculate the value of A cross B, the magnitude. Okay, and of course I will not go into the details of what other exercises we can do, etc., and associative law of vector product, etc. Right now I'll just give you an example. I'll give you an example wherein I have, suppose my A is, allow me to rub it off this part, and now my A is equal to, for example, a vector R, which is displacement vector R, which is in meters, and my B is equal to vector F. So we can define R cross F. Okay, I can define R cross F, and the R cross F as an application, I'm just telling you R cross F. Now this is in meters and this is in newtons. So R cross F I can calculate the same way, and this is nothing but the torque that will come to in the two-dimensional motion, etc., volume, and the unit will become meter Newton. The unit becomes meter Newton, and here I just want to discuss to you and wind up this lecture that Newton meter is different from meter Newton, in the sense that this Newton meter, which is actually the unit of work done, and this is the unit of torque. This has got another unit, work done in joules, etc. So we'll come back to you, inshallah, and I hope that you have enjoyed the cross product, the definition, the values, and what happens, and this and that, and this will suffice you to equip you to deal with any situation of cross product. Dot product I've already done. So two vectors A and B. There are other rules, other laws associated with the vectors positioning, but this is the gist of the thing which you must have here, and you should be able to do that like you change the gear of your car or motorcycle, or how you button your shirt. You don't look at the things and do it. This is what is needed which will equip you to do physics. And for now, thankful to you for listening to me carefully. Okay, if we put some numerical values, then things become very easy. 0, 1, 2, -2, etc. These numerical values for AX, AY, AZ, BX, BY, BZ. So we obtain a value of CX, CY, CZ, etc. And we are happy that the magnitude has been determined by us. So that's all for the day. Thank you very much.